In this presentation, I'm going to talk about failure mode and effect analysis. It is a bit different with the previous topic of trees because in trees, it helps us to categorize the problem that we have. For example, if the problem is categorized as a technical contradiction, trees will offer some possibilities, ideas to solve our problems in the form of the matrix of the inventive principles. So trees gives us a little bit more about how to categorize our problem and also gives us ideas about the possibilities to solve those design problems. In FMEA, I think it's a bit different because it does not gives us any ideas. Instead, it will guide us to systematically think about our design and think about the problems that may occur. So let's look at how this FMEA works. FMEA basically helps designers to improve either product or process by asking these questions. First is what can go wrong? So we think about all the possibilities that something in our design or in our process that can go wrong. We think about all the possibilities that something in the design of the product or process can go wrong. Furthermore, another question is that where can variations come from? So for examples, we consider that the different customer usages of a product might give a different variations of the failure of the product. So to answer these two problems, the designers and the design team should study and understand the process structures, should map the process, how it goes, which component goes to which component, what is the effect from one process to the others. Also, it needs to really understand what customer wants, what are the needs, what delights customer, what makes them happy. So the design team should understand about this customer context as well to identify what can go wrong and how severe are the effects of those failures. And then also from the product itself, the designer needs to understand what are the performance requirements of the product. What is required from the product? How is it supposed to work? What kind of performance should the product deliver? And then the designer should also think about the causes of deterioration, or how does the product get worse as the customer is using the product over the product's life. So not only the failures at this moment, but also the possible failures in the future along with the product life. And then to understand what can go wrong with a product, designers must also go back to the basic drawings of each component of the product to think about, oh, probably this can go wrong. Oh, maybe this part can fail if that happens. So designers really need to look at the drawings and specifications of each component of the product and really think about what can go wrong, what can fail from that component. So this FMEA analysis can be applied to either design FMEA or process FMEA. The difference is just that in the design FMEA, we analyze the product designs before they are released to the production line. In the process FMEA, we analyze the processes. So not the physical design of a product or an object, but it's about analyzing the process. We can use FMEA for both design of the product and the design of a process. So FMEA is really a systemic group of activities. There are three main activities in FMEA. First, we need to recognize the potential failures. What can cause failures in this product? And these are called the failure modes. So we try to identify what are the possible causes of failure of a product or a process. And then after we can identify all the possible failures and causes of those failures, we also think about what are the effects of each failure. So recognize the potential failures, the causes of those failures, and then also think about the effects. Once we have done that, we identify actions which could eliminate or reduce the chance of those potential failures to occur. So again, FMEA does not give any ideas or suggestions to eliminate or reduce the potential failures, but it just guides us to think about it. And then finally, we document the entire process such that in the future, if we are trying, let's say, to improve this product to the next generation, we have the documents about this entire process of identifying the potential failures and the possible actions that we have taken for this generation of the product. FMEA might be summarized in a worksheet like this. So this worksheet is something that the design team should fill each column carefully, and then finally in the column 10, the design team should think about the actions recommended for each potential failure mode. We'll see each of this column and what we should fill in each of this column in the next slides. So in the first column, we need to define the scope of our problem, the functional requirements of the product or the design parameters, and the process steps. So functional requirements are all functions that are expected from the product. In other words, what does a product should be able to do? So these are all the functions that are required from a product. We might also think about the design parameters, which means that if we have several alternatives of product concepts, how are we going to say that this alternative is better than that? For example, we can compare those two alternatives based on the parameter of the function or the performance, which one performs better. We can also compare alternatives based on the cost, based on the environmental issues, safety, quality, energy consumption, reliability, service life, and so on. So we define the scope of our problem, of our design problem. What are the functional requirements or the design parameters that we're going to measure the alternatives and the process steps. To help the design team to do this, we can translate the physical structure of an object or product into block diagram in the next slide. The block diagram will help the design team to determine the scope, which means that which component, which processes are included in the scope of our problem, and which component, which processes are excluded from our problem. What functions are included, what functions are not, and so on. And then based on the functional requirement and the diagram, we later may identify potential failure modes. So how can we identify failure modes? Well, if there's a functional requirement that cannot be delivered, So the functional requirement, it is a function that is required, but then the current design cannot deliver that. So it's a failure, right? Or if we think about right now, the product can deliver that function, but over time, it is degraded. Then it's also a failure mode. And then also if the function is delivered intermittently, it means that sometimes it is delivered by the product, sometimes it's not, which means that sometimes the product functions well, sometimes it doesn't. It is also a failure. And then if based on the diagram, if we see that, oh, apparently this design also delivers something that is not intended. So there's a function that is not intended, but it is delivered by the product. It is also a failure, especially if this function has some harmful effect to the customer. So this is an example of a block diagram which shows us all the components, how each component is interacting with the other components in the product. And we can also from here see what are the potential failure, and suppose one component fail, how it will affect the other components. And then we can also see from this diagram what kind of functions are actually delivered successfully, what kind of functions are not. So this diagram will really describe everything that is happening inside the product and helps us to think about which function that may go wrong. Based on the identification from the block diagram, we write down the potential failure modes in the second column. So to help the design team to identify all potential failure modes, this question might be asked. In what way does the design fail to perform its functional requirements? So think about all the possibilities that make the product fail to perform the function that it should deliver. Potential failure modes may also be studied from a previous report or previous baseline and from the current data, test, and current FMEAs. So the design team can study the data from the previous generation or previous analysis, may also conducting tests on current design to see what are the possible failures and causes of those failures. Continuing from the second column, where the design team has already identified the potential failure modes, in the third column, the design team should think about what are the effects of each failure mode. So if this fails, what are the effects? And those effects are written in the column 3. So column 2 talk about the failure mode, what can fail and what are the causes of that failure. Column 3 talk about the effect if that kind of failure happens. Now column 4 talks about how severe is the effect of that failure. So column 4 talks about the severity of the effect of the failure. So for example, if component X fails, the effect is very severe, it's very bad. It causes hazard. But then let's say if component Y fails, then the effect is just something minor. How we can tell how severe the effect of a failure? It's kind of subjective, and then people usually use this kind of rating. So let's say rating 1 is that if something fails, and then the effect is there's no effect on the product. So we give the smallest rating 1. So I show here is truncated table. So I just showed the example how the severity goes up from 1 to 2 to 3, and then in the other extreme is the severity rating of 10, in which that the effect is hazardous, is very dangerous, and it also comes without warning. Because it comes without warning, then this effect is very dangerous, because it just happens and nobody knows that it is going to happen. So in column 4, the design team should write down the subjective rating about how bad they think that the effect of the failure is. If it is very bad, then the severity rating is high. If it's very small effect or even no effect at all, then the rating is small, just 1. And anything between them has the rating in between 1 and 10. After identifying the failure mode effect, how severe the effects are, now FMEA wants the design team to think about the potential causes for each failure mode. So usually the causes are one of these 3 possibilities. The design is not manufactured or assembled within the provided specifications. So it is produced out of the specifications, or it is assembled out of the specifications. Or maybe the design itself includes a deficiency or vulnerability that may cause unacceptable variations. So there is something in the design itself such that the variation of the components or the products that is produced can be very high, which causes misbuilt, misassembled, errors in the assembly, and so on. And sometimes both causes happens. The design itself has a deficiency, and then when it is produced or manufactured, it also not produced within specifications. So in column 5, FMEA wants the designer to think about what are the potential causes for the failure mode in column 2. In column 4, we've talked about how severe the effects of a failure mode. Now in column 6, we need to give another subjective rating to say how likely that the failure mode occurs. So how likely the failure mode in column 2 occurs. Because some failure mode, they might be very likely to happen in your product, but some maybe not. Again, the rating is subjective, and this is just an example of occurrence rating. So if it's the probability of failure is very high, and then you give a high rating for this occurrence. And then if it is very unlikely to happen, you give a small rating. In column 7, the designers talk about how much design controls that has been provided or thought about to anticipate the failure. So design control is that when you have a design and then you try to have a control over the design by trying to identify and detect the design deficiencies and vulnerabilities as early as possible. So you try to control all the bad things that may come out from the design. So in column 7, the design team write down what are the design controls that has been thought about so far. So what are the examples of these design controls? Well, it may include some lab tests, so test the strength, for example, in the lab, and then also it may include project and design review. It might also include some design modeling using some simulation tools to see that, let's say if the force is this much, whether the product can handle it or not. So those kind of controls try to see as early as possible what are the vulnerabilities of the design. And if this has been done, then the designer should write down all these controls that has been done in column 7. Column 8 is still related to column 7, which we give a subjective rating about how good we think that our control that has been done in column 7. So yes, you have a design control. For example, you do a simulation, but then how good is that simulation to detect the failure mode? So this detection rating gives you that kind of rating to rate how good is your design control. So if your design control is very good, then it can almost certain to detect any deficiencies. So the rating is 1. It will almost certainly detect a potential cause or mechanism and the subsequent failure mode. So this is a very good design control. It can detect almost certainly anything that is going to be wrong with the design. But then if the design control will not or cannot detect a potential cause of a failure mode, or there's no design control that has been thought about, then the rating is 10, which is the worst, because right now the design team does not even have an idea about how to control the design. So we have 3 ratings so far: the severity of the effect, and then how likely we think that this failure mode occur, and then the rating of how good we think our current design control is. Now in column 9, we multiply these 3 ratings. So severity times occurrence rating times detection rating. The RPN number is called the risk priority number. The larger the number is, the worse, not really the worst, but the higher priority that we should give to that failure mode, because it is very risky. Okay. And then what we want to do when we try to define the potential action is that we can try to reduce the severity. So the effect is still there, but we reduce the severity of the effect such that the effect is not very bad for customers or for the function of the product. We may also try to reduce the likelihood or the probability that something occurs. So we can try to reduce the frequency of it might occur. Or we can also try to do better by increasing the detection capacity of our design control. So any of them will reduce the RPN number. So to reduce the risk, we can try to reduce the severity, reduce the occurrence, or increase the detection capacity. Or we may just do all of them simultaneously to reduce the risk priority number. So these are the tables that shows example of the compiled rating. So let's say in the first row here, if the severity is very bad, hazardous, and without warning, the likelihood of occurrence is also very high, which means failure is almost certainly happen, which is very bad. And then we do not have any design control to detect the failure, the rating is the worst. On the other extreme, the rating is very small when the effect does not have any meaningful effect even if the failure happens, and then it does not seem likely to occur, and then our design control can almost certainly detect failure, then the rating is small. And anything is between between those two extremes. Finally, in the last column, based on the RPN numbers, the design team should think about the actions recommended for each failure mode. Based on the risk priority number, the design team can see which failure mode should be prioritized because it has the highest risk. Now let's see an example where the design process applies FMEA. It's the design of a medical walker, and then you might want to watch this short video to see how a walker works. I mean, how people can use this walker. Because when I first looking at this design, I didn't really understand like how can people sit on this walker and why is there a seat in the walker. Then I watched the video and then I understand, oh, okay, that's how it works generally. So let's take a look a little bit about the project. It's about redesigning a walker such that the new design is expected to be more ergonomic for climbing slopes or going up and down the stairs. The design also seeks to improve the grip support, the adjustment of height and width, and the fold-up mechanism. So the walker can be folded into smaller form such that it may be stored easily. The problem statement is that the current walkers in market demands force and repetitive motions from the user, which can cause discomfort and pain. Among all design alternatives in the project, this is the final design concept that they selected. So let's take a look at how this design team applies FMEA to their product concept. So they look at the hand grip component. The function is this hand grip provides support and guidance to conduct the walker. So it helps the user when the user wants to drive this walker, to turn left, to turn right, or just move straight forward, for example. The potential failure modes for this hand grip, there are two potential failure modes. The first one is the hand grip becomes loose, and then the second one is the hand grip deformed, changing in the shape, or it starts to cracking. Let's see the first potential mode. If the hand grip becomes loose, it will provide less support to the user, such that it might injure the user's wrist because the grip is loose. The severity is 4, is pretty high, and the potential causes is the severe temperature change from hot to cold and from cold to hot. The occurrence is pretty low for this cause to experience the severe temperature change. And then the current detection control is using non-circular cross-section, and it is pretty good because the detection rating is low. So low rating for detection means the detection is doing good. Now the RPN for this is 16, and then the recommended action is try to ensure that this hand grip is non-load bearing, means that it does not being the focus of the load of the user or the entire structure of the product. Now for the second potential failure mode, deformation or cracking. If the hand grip changes in shape or cracks, it may cause some discomfort or injury to the user. The severity is smaller than the previous failure mode. What can cause the hand grip to deform or cracks? Apparently, it may be caused from the UV lights. It causes the hardening on the materials of this hand grip, and the likelihood of the occurrence is 2. It's pretty low. However, currently we don't have any detection control to detect that the hand grip is deformed or hardened. That's why the detection rating is high. Means that it is bad. We don't have any detection control method. Now the total RPN number becomes higher than the previous one, so it may become a higher priority for the design team to solve. One of the recommended action is that we use a material that is more UV compliant. Means that even though it receives a lot of UV lights, it does not deform or cracking. Now let's look at the other components here. It says here that they're talking about the back support. However, in the design, I don't know if I miss it or anything, but I don't see any back support in this design. Back support is something that may support the back of the user when he or she sits down on this walker. So the potential failure is that if the height of this back support is not in proper position, it may result in a fall of the user, and of course, it is very severe. How can that happen? Well, if the user did not check the suitability of the support, it may be too high or maybe too low. And the likelihood of this is pretty low too. But then there's no detection control at this moment. So detection rating is 5. The RPN is high, and then the recommended action is that try to create a support feature that can be adjustable according to the person's height or weight. Now the second component here is about the seat itself. This is the place where the user will sit down. The potential failure mode is that the fabric will tear or the stitching fails such that it results in a fall. Again, the severity is high because if people fall from this walker, it is hazardous, very dangerous. The potential causes is if the fabric rottens or UV hardening happens. The current control is using visual inspection, and the recommended action is under the seat, adding another Kevlar fabric to strengthen the seat to prevent it from the tears or the stitching fails. The analysis goes on to the elbow rest assembly, and the potential failure mode for this elbow rest assembly is again similar to hand grip. Either it is getting loose or it is deformed or cracked. For the horizontal stabilizer bar here, it provides the horizontal stability for this walker. It may fail when the scissor pin fails or the scissor bar buckles. Same as before, we try to rate the severity, rate the occurrence of the potential failure causes to happen, rate the detection ability of the current design control, and then look at the risk priority number to see whether that potential failure is in high priority or in a lower priority to be solved. And then they're also looking at the front wheel assembly, rear wheel assembly, brake system assembly, and a walker frame. So you can see that in this project they look closely at each part or each sub-assembly to think about what kind of failure that might happen. And then using the FMEA worksheet, follow through each column to finally think about the potential recommended action in the last column. Okay, so that's the end of this FMEA presentation. Thank you.